right, we're back. We're going to spend another day on vertex form and quadratic functions. So we did the first 3 examples in the book in the last video. Now we're going to do the last 2, right? So here's what I'm going to do. Instead of writing this whole problem down, I'm just going to show it to you really quickly. So this, we're going to start with this example form. So it says, do it like... Okay, so let's just read it. The height of a thrown ball is a quadratic function of the time it has been in the air. The graph of the quadratic function is the parabolic path of the ball. The vertex of the graph is 1, 20, and the path of the ball includes the point 0, 4. What is an expression that defines this function? Write the quadratic equation in vertex form and in the form y equals ax squared plus bx plus c. This is actually called standard form, which we're going to learn in the next video, but they want us to write it in both. So here's this guy throwing the ball, and you can see it starts here at 4 feet because apparently that's where he launched it, right? That's where his hand was at 4 feet. The ball did not start at the ground. It started somewhere at his arm level. So it started at 4 feet. He threw it up. It meets or it has the maximum, right? After 1 second, it's 20 feet high, and then it starts to come down. So you can imagine the trajectory like this. Okay, so let's write this equation. So remember that vertex form is this, where the vertex is at h, k. Okay, so we know a couple things. We know that the vertex of that ball was at 1, 20. So 1 second, it was 20 feet high, and it also includes the point 0, 4. So those are the only 2 things they gave us. So let's see. Well, right away I can plug in my HK. So I know that I can x minus h, well h is 1, squared, plus k, well k is 20. So I know that so far. So the only thing I really need is this a. So to figure out a, I need to plug in something for x and plug in something for y so that I can solve for a. Well, they gave us a point, so let's plug that in. So the y is 4 equals a. X at that point is 0. Okay, let's solve for a. 4 equals 0 minus 1 is negative 1. Negative 1 squared is 1, so it's just a plus 20. Take 20 away from both sides. Negative 16 equals a. So my final equation in vertex form is y equals negative 16 x minus 1 squared plus 20, right? All I did was plug in what we saw for a for the answer. So that was part of the answer because it asked us to write it in vertex form, and then it also asked us to write it in standard form. So standard form is this. Okay? Okay, so how can we get that in standard form? Well, we can just multiply it out, right? If I multiply this out, I'll have an x squared term. So if I multiply this out here, the first thing I need to do is square this. So I'm just going to come over on the side and work that out in case you guys forgot how to do this. So there are rules for squaring this, and I don't have the rules memorized. I just do it in my head really quickly, just like you guys have memorized multiplication tables and do those in your head really quickly. But I'm going to work this on the side so you can remember. So that some people remember this trick FOIL, right? The first with the first, then the outer with the outer, and the inner with the inner, and the last with the last. That's too complicated for me. I just remember, like, I have to take it and go, okay, here's my x. I need to multiply it by every number over here. And then I take my negative 1 and multiply it by every number in the second parentheses and add them. So the way if I start with x, well, x times x is x squared. X times negative 1 is negative x. Now I come to my second term. Negative 1 times x is negative x. And negative 1 times negative 1 is plus 1. And then when I simplify that, it's x squared. This becomes minus 2x when I combine those, right? Plus 1. So that is what happens when you work out that exponent there. So you'll be able to start doing those in your head if you don't know it already, the more you practice. So what I have now is y equals negative 16, and instead of this x minus 1 squared, I'm going to write out what we got. So that's x squared minus 2x plus 1, and I still have that plus 20 on the end. So now let's distribute that negative 16. So I have negative 16x squared. Negative 16 times negative 2 is 32x, positive 32x. Negative 16 times positive 1 is minus 16 plus 20. Hopefully you can see that you can combine those like terms. Negative 16 plus 20 is plus 4. So that is the this equation in standard form. They're both the same thing. One's just been expanded out, right? Figuring out what that squared term is. Okay, so now let's do one more. I might show you the example from the book again so I don't have to write all this. Okay, so here, let's look at this. We're doing example 5. It says the function g, so this blue function, is a translation of the parent function, the original function f, this red one. It is 1 unit left, boop, and 3 units up. Boop, 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 right there. Yeah, that makes sense. What is the equation of g? Write the quadratic equation in vertex form and in standard form, right? So I'm going to come back here, and I know, well, one thing I know is if I look at this original function, this red function, the parent function f, hopefully you guys see that's just a basic x squared function, right? The vertex is at 0, 0. X squared, if I plug in 1, I get 1. If I plug in 2, I get 4, and it's mirrored on the other side. So I know, if I come over here, I know that the parent function f of x is just x squared. Okay? And then they've also told us that it's been moved to get to g of x. We had to move it left 1 unit, and then we had to move it, what was it? Up 3. So left 1, up 3 gives you g of x. Okay, so vertex form is going to be this. Okay, so if I'm moving the entire graph left 1 and up 3, instead of the vertex being at 0, 0, hopefully you guys can see now that my vertex, my HK, if I move it left 1, it's going to be at minus 1, and if I move it up 3, it's going to be at 3. So my HK is this. So I can plug those in. X minus negative 1 is going to become x plus 1 squared plus 3. Okay, so now we're in the same boat as last time, except where we need to figure out a. So we need a point on the graph of g of x. We're not going to use the vertex because that would give us 0. Right? So what's another point we could use? Well, I come in, look at the graph. I could use any point along g. So one point I could use is 0, 4. So let's use that, 0, 4. So let's plug in the point on g of x is 0, 4. Okay, so g of x, oops, so instead of g of x, our y value, we're going to plug in 4. 4 equals a, x is 0, plus 1 squared plus 3. So 4 equals, well, that's just 1, so a plus 3. So take away 3 from both sides, 1 equals a. So my final equation for g of x is now 1, which I don't need to write. X plus 1 squared plus 3. Okay, so that's part of it. They also wanted us to write it in standard form, so we have to expand this thing out. So what's x plus 1 times x plus 1? Well, that's x times x is x squared. X times 1 is just x. X times 1 is just x. 1 times 1 is just 1. So this comes out to be that. So now when I plug that in for g of x, I have x squared plus 2x plus 1. And then I still have this plus 3 on the end. So when I combine those, I get that, right? So here's standard form. And where does my vertex form go? And here's vertex form. My 2 solutions. Okay?